Welcome to the ISTQB CT-GenAI exam prep series by AmitAutomates. In this video, Chapter 2B, Applying GenAI to Testing and Evaluation. You will practice 30 questions, each with 4 segments. The question is read aloud, then a pause screen gives you time to choose, then the correct answer is revealed, then a full explanation follows. Every question shows its learning objective code and K level. This content is based on the official ISTQB CT-GenAI syllabus. Let's begin. Question 1. Learning objective GenAI 2.2.1. Difficulty level K3. A test team wants to use prompt chaining to generate prioritized test conditions from stable, thoroughly reviewed requirements. Which combination of steps is most appropriate? Your options are A. Generate test conditions from requirements prioritized by risk level with acceptance criteria as context. Perform coverage analysis to ensure all requirements are addressed. B. Generate test conditions from requirements. Identify defects and ambiguities in requirements. Prioritize test conditions by risk level. C. Submit all requirements in one comprehensive prompt. Allow the LLM to determine appropriate steps. Review final output. D. Perform coverage analysis. First, generate test conditions. Identify defects in requirements. Prioritize by risk. Take a moment. What is your answer? The correct answer is option A. Generate test conditions from requirements prioritized by risk level with acceptance criteria as context. Perform coverage analysis to ensure all requirements are addressed. Explanation. The correct prompt chaining sequence: 1. Generate test conditions from requirements. 2. Prioritize by risk level with acceptance criteria as context. 3. Perform coverage analysis to verify all requirements are addressed. Identifying defects is outside scope since requirements are stable. Submitting everything in one prompt contradicts prompt chaining's purpose of decomposing tasks. Low GenAI 2.2.1 K3. Question 2. Learning objective GenAI 2.2.1. Difficulty level K3. A tester wants to use GenAI to help identify test conditions for a new feature. The requirements are ambiguous in several places. Which approach best leverages LLM capabilities for test analysis? Your options are A. Generate test conditions directly and ignore the ambiguities. The LLM will resolve them internally. B. First prompt the LLM to identify ambiguities and ask clarifying questions, then use the clarified requirements to generate test conditions. C. Ask the LLM to generate test conditions and then ask it to identify defects in the same prompt. D. Skip test analysis and proceed directly to test design. The LLM can generate test cases without test conditions. Take a moment. What is your answer? The correct answer is option B. First prompt the LLM to identify ambiguities and ask clarifying questions, then use the clarified requirements to generate test conditions. Explanation. When requirements are ambiguous, the recommended approach is a two-step process using prompt chaining. 1. Prompt the LLM to identify ambiguities and raise clarifying questions. 2. Once requirements are clarified, use the LLM to generate test conditions. Ignoring ambiguities risks incorrect test conditions. Combining analysis and defect identification in one prompt reduces quality. Skipping test analysis entirely removes the foundation for test design. Low GenAI to 1 K3. Question 3. Learning Objective GenAI to 1. Difficulty level K2. Which of the following represents an appropriate application of GenAI to test analysis for a web application's user authentication feature? Your options are A. Using the LLM to directly execute test cases against the authentication endpoint and record results. B. Using the LLM to identify test conditions such as valid credentials, invalid credentials, account lockout, and session timeout from the authentication requirements. C. Using the LLM to write production code that implements the authentication logic, then testing it. D. Using the LLM to automatically deploy the authentication service to a test environment for immediate testing. Take a moment. What is your answer? The correct answer is option B, using the LLM to identify test conditions such as valid credentials, invalid credentials, account lockout, and session timeout from the authentication requirements. Explanation. Test analysis with GenAI involves using the LLM to derive test conditions from requirements, identifying the scenarios and situations that need to be tested, valid credentials, invalid credentials, lockout, session timeout. LLMs cannot execute tests, write production code, or deploy services. Identifying test conditions is the core test analysis activity described in GenAI to 1. Low GenAI to 1 K3. Question 4. Learning Objective GenAI to 1. Difficulty level K3. A tester uses an LLM to analyze a requirements document and generate a list of test conditions. After reviewing the output, the tester notices several test conditions that address scenarios not mentioned in the requirements. What should the tester do? Your options are A. Accept all generated test conditions as the LLM likely identified implicit requirements the tester missed. B. Reject all generated test conditions and rewrite them manually without LLM assistance. C. Review each extra test condition against the requirements to verify if it represents a legitimate missing requirement, a hallucination, or an out-of-scope scenario. D. Rerun the same prompt. The duplicate results suggest a tokenization error that will be corrected on retry. Take a moment. What is your answer? The correct answer is option C. Review each extra test condition against the requirements to verify if it represents a legitimate missing requirement, a hallucination, or an out-of-scope scenario. Explanation. When an LLM generates test conditions beyond the stated requirements, the tester must critically review each one. Some may reveal legitimate gaps in the requirements, valuable, others may be hallucinations, incorrect, and others may be out of scope. Simply accepting or rejecting all conditions is wrong. Human judgment is essential to validate LLM test analysis outputs. Low GenAI to 1 K3. Question 5. Learning Objective GenAI to 1. Difficulty level K2. Which statement best describes the role of GenAI in test analysis within the CT-GenAI syllabus? Your options are A. GenAI replaces the test analyst entirely by automatically producing verified test conditions from requirements. B. GenAI assists the test analyst by generating test conditions, identifying coverage gaps, and highlighting ambiguities, with the analyst reviewing and validating the outputs. C. GenAI performs test analysis only for non-functional requirements such as performance and security tests. D. GenAI performs test analysis exclusively through integration with formal modeling tools like UML state machines. Take a moment. What is your answer? The correct answer is option B. GenAI assists the test analyst by generating test conditions, identifying coverage gaps, and highlighting ambiguities, with the analyst reviewing and validating the outputs. Explanation. The CT-GenAI syllabus positions GenAI as an assistant to the test analyst, not a replacement. GenAI can generate test conditions, highlight ambiguities in requirements, and identify coverage gaps, but the test analyst must review, validate, and take responsibility for the final outputs. GenAI applies to all test types, not only non-functional. It does not require UML tools. Low GenAI 2.2.1 K3. Question 6. Learning Objective GenAI 2.2.2. Difficulty Level K3. A tester must generate comprehensive Gherkin-style test cases for the acceptance criterion. A user must be able to log in with valid credentials. They have two existing Gherkin test cases to use as examples. Which prompt best ensures well-structured, comprehensive results? Your options are A. Generate test cases for user login using predefined examples for guidance. Apply best practices for format and coverage. B. You are an expert test designer. Generate comprehensive Gherkin test cases in given-when-then format. For a user must be able to log in with valid credentials. Use these two existing test cases as structural examples, example 1, example 2. Cover the main success scenario and key alternative flows. C. Create test cases for the login feature. Apply Gherkin best practices for format and structure. D. Generate edge case and negative test scenarios for login in given-when-then format. Focus primarily on invalid and boundary conditions. Take a moment. What is your answer? The correct answer is option B. You are an expert test designer. Generate comprehensive Gherkin test cases in given-when-then format. For a user must be able to log in with valid credentials. Use these two existing test cases as structural examples, example 1, example 2. Cover the main success scenario and key alternative flows. Explanation. Option B is comprehensive. It establishes the role, explicitly requires given-when-then syntax, ties output to the specific acceptance criterion, provides two few short examples for structure, and specifies coverage scope. Options A and C lack the examples and given-when-then requirement. Option D narrows scope to edge cases and misses main scenario coverage. Low GenAI 2.2.2 K3. Question 7. Learning Objective GenAI 2.2.3. Difficulty Level K3. A tester asks an LLM to generate test data for an e-commerce order submission feature. The LLM returns only positive test data with valid inputs. Which improvement to the prompt would best generate comprehensive test data? Your options are A. Add a role component. You are a test data specialist. B. Add a constraint. Cover valid inputs, invalid inputs, boundary values, and special characters for each field. C. Add an output format. present data in a CSV table with column headers. D. Add context. This is an e-commerce order system processing international transactions. Take a moment. What is your answer? The correct answer is option B. Add a constraint, cover valid inputs, invalid inputs, boundary values, and special characters for each field. Explanation. The missing component is a constraint that specifies the types of test data required. By explicitly instructing the LLM to cover valid, invalid, boundary, and special character cases, the tester directs comprehensive test data generation. Adding only role, output format, or context without specifying the data types will not address the gap in coverage. Low GenAI 2.2.2 K3. Question 8. Learning Objective GenAI 2.2.2. Difficulty Level K2. Which of the following is a valid application of GenAI to test design, as described in the CT-GenAI syllabus? Your options are A. Automatically executing generated test scripts against the system under test. B. Generating test cases, test scripts, or test data from requirements and test conditions. C. Deciding which test cases to include in a regression test suite based on risk analysis. D. Reviewing production code to identify logic errors before testing begins. Take a moment. What is your answer? The correct answer is option B. Generating test cases, test scripts, or test data from requirements and test conditions. Explanation. Test design with GenAI involves generating test cases, test scripts, and test data from requirements and test conditions. This is the direct application described in Low GenAI 2.2.2. LLMs cannot execute tests autonomously, make risk-based regression decisions independently, or perform production code review in the test design phase. Low GenAI 2.2.2 K3. Question 9. Learning Objective GenAI 2.2.2. Difficulty Level K3. A tester generates Gherkin test cases using an LLM and notices that all generated scenarios use the exact same given clause. What is the most effective way to address this in the next prompt? Your options are A. Use meta-prompting to ask the LLM to redesign its own prompt and then regenerate. B. Add a constraint to the prompt specifying that each scenario must have a unique given clause describing a distinct precondition. C. Switch from few-shot to zero-shot prompting to prevent the LLM from copying the same given from the examples. D. Lower the LLM's temperature parameter to reduce repetition in the given clauses. Take a moment. What is your answer? The correct answer is option B. Add a constraint to the prompt specifying that each scenario must have a unique given clause describing a distinct precondition. Explanation. Adding an explicit constraint that each scenario must have a unique given clause with a distinct precondition directly addresses the issue. The problem is that the prompt lacked a constraint around precondition diversity. Temperature affects randomness at the token level but doesn't ensure structural diversity in Gherkin format. Removing examples, zero-shot, risks losing the format guidance. Meta-prompting adds overhead without directly fixing the constraint gap. Low GenAI 2.2.2 K3. Question 10. Learning Objective GenAI 2.2.4. Difficulty Level K3. A tester is using an LLM to analyze test execution results, but the current prompt generates vague summaries without actionable insights. Which prompt revision best improves the analysis quality? Your options are A. Analyze test results. Cluster similar issues together and cross-check against requirements. Provide a summary of findings. B. As a senior QA analyst, analyze the provided test execution results and generate a comprehensive findings report. C. Analyze the test results by 1. Separating expected results from actual results to identify mismatches. 2. Clustering similar issues to reduce redundancy and aid prioritization. And 3. Highlighting critical discrepancies. Present findings in a structured format with severity classification. D. Analyze only the test results from the last 24 hours. Ignore any historical patterns or trends in the data. Take a moment. What is your answer? The correct answer is option C. Analyze the test results by 1. Separating expected results from actual results to identify mismatches. 2. Clustering similar issues to reduce redundancy and aid prioritization. And 3. Highlighting critical discrepancies. Present findings in a structured format with severity classification. Explanation. Option C expands instructions to include all critical structured analysis steps, separating expected from actual results, pinpoints mismatches, clustering issues, reduces redundancy, and highlighting discrepancies. Option A is incomplete, it misses separating results. Option B improves role clarity but adds no concrete analytical steps. Option D introduces an irrelevant constraint that limits analysis scope. Low GenAI 2.2.3 K3. Question 11. Learning Objective GenAI 2.2.4. Difficulty Level K2. A team is using GenAI to support automated regression testing. Which of the following represents an application of GenAI to automated regression, as described in the CT-GenAI syllabus? Your options are A. Using an LLM to generate keyword-driven test scripts that can be automatically updated when the UI changes. B. Using an LLM to manually classify each regression test as pass or fail after observing the execution results. C. Using an LLM to replace the test execution engine so it can run regression tests without external tools. D. Using an LLM to manage the CI/CD pipeline and deploy new builds before regression tests run. Take a moment. What is your answer? The correct answer is option A. Using an LLM to generate keyword-driven test scripts that can be automatically updated when the UI changes. Explanation. The CT-GenAI syllabus describes using GenAI to generate keyword-driven test scripts and to support self-healing test automation, where scripts are automatically updated when the application under test changes. This is a direct application to automated regression testing. Manual classification, B, is not automation. Replacing the test engine, C, and managing CI/CD, D, are beyond LLM capabilities in the testing context. Low GenAI 2.2.3 K3. Question 12. Learning Objective GenAI 2.2.4. Difficulty Level K3. An automated regression suite has tests that fail sporadically after each UI update because element locators change. Which GenAI capability most directly addresses this problem? Your options are A. Using the LLM to generate new test cases every time a UI update occurs. B. Using the LLM to support self-healing test automation by identifying and updating broken locators automatically. C. Using the LLM to analyze performance metrics and determine if the UI updates affect response times. D. Using the LLM to perform exploratory testing of the updated UI and report new defects. Take a moment. What is your answer? The correct answer is option B, using the LLM to support self-healing test automation by identifying and updating broken locators automatically. Explanation. Self-healing test automation is a key application of GenAI to automated regression testing described in the CT-GenAI syllabus. The LLM can analyze the changed UI, identify which locators are broken, and suggest or apply updated locators, keeping the regression suite functional after UI changes. Generating entirely new test cases each update is inefficient and doesn't address the locator problem directly. Low GenAI 2.2.3 K3. Question 13. Learning Objective GenAI 2.2.4. Difficulty level K2. Which of the following best describes how GenAI supports test impact analysis in automated regression testing? Your options are A. GenAI executes all regression tests and identifies which ones are impacted by code changes through trial and error. B. GenAI analyzes code changes and maps them to related test cases, helping the team identify which tests are most likely to be affected. C. GenAI replaces the regression suite entirely by generating new tests for every code change. D. GenAI reviews test execution logs after a full regression run to identify which tests were impacted. Take a moment. What is your answer? The correct answer is option B. GenAI analyzes code changes and maps them to related test cases, helping the team identify which tests are most likely to be affected. Explanation. Test impact analysis with GenAI involves analyzing code changes and mapping them to related test cases or coverage areas, enabling the team to focus regression efforts on the tests most likely to be affected. This is the proactive application described in the CT-GenAI syllabus. LLMs do not execute tests or replace regression suites, they analyze and recommend. Low GenAI 2.2.3 K3. Question 14. Learning Objective GenAI 2.2.5. Difficulty level K3. A test manager wants an LLM to generate a metrics report that stakeholders can easily understand and act upon. The current prompt generates raw numbers without interpretation. Which addition to the prompt best addresses this? Your options are A. You are a senior QA analyst with deep knowledge of agile metrics. Generate the test metrics report for this sprint. B. Generate a test metrics report and include a risk analysis section identifying potential risks for each metric that falls below threshold. C. Generate the test metrics report and add a plain language summary that interprets each metric, explains what it means for project health, and outlines recommended next steps for the team. D. Ensure the generated metrics report follows the exact same formatting and structure as all previous sprint reports. Take a moment. What is your answer? The correct answer is option C, generate the test metrics report and add a plain language summary that interprets each metric, explains what it means for project health, and outlines recommended next steps for the team. Explanation. Option C directly supports stakeholder understanding and actionability by requiring a plain language summary that interprets metrics and outlines next steps. Option A adds only role clarity without improving interpretability. Option B adds risk analysis, which may distract from the core metrics understanding needed. Option D merely restates a formatting constraint without adding interpretive value. Low GenAI 2.2.4 K3. Question 15. Learning Objective GenAI 2.2.5. Difficulty level K2. Which of the following represents an appropriate application of GenAI to test monitoring and control? Your options are A. Asking an LLM to automatically halt a test execution pipeline when a critical test fails. B. Asking an LLM to generate a natural language summary of test progress metrics for a sprint review dashboard. C. Asking an LLM to modify the test execution schedule in real time based on defect severity. D. Asking an LLM to archive test results in the test management system at the end of each sprint. Take a moment. What is your answer? The correct answer is option B, asking an LLM to generate a natural language summary of test progress metrics for a sprint review dashboard. Explanation. GenAI in test monitoring and control supports generating natural language summaries, interpreting metrics, and creating reports that communicate test progress clearly. Automatically halting pipelines, modifying execution schedules, and archiving results are automation tool integration tasks that require dedicated infrastructure, not LLM-generated outputs. Low GenAI 2.2.4 K3. Question 16. Learning Objective GenAI 2.2.5. Difficulty level K3. A test team uses an LLM to generate a weekly test status report. The LLM produces accurate data but presents it in technical language that non-technical stakeholders struggle to understand. What is the most effective prompt improvement? Your options are A. Add a role component. You are a data analyst specializing in statistical reporting. B. Add to the output format. Write the summary in plain, non-technical language for a business audience. Avoid acronyms and jargon. C. Switch to prompt chaining. First generate the technical report, then chain a second prompt to translate it. D. Use few-shot prompting to provide 3 examples of previously approved stakeholder-friendly reports. Take a moment. What is your answer? The correct answer is option B. Add to the output format. Write the summary in plain, non-technical language for a business audience. Avoid acronyms and jargon. Explanation. Since the data is accurate but the language is too technical, the fix is an output format constraint addition specifying the audience and language style. Option B directly addresses the communication issue. Option A changes the role but doesn't guarantee non-technical language. Option C adds unnecessary complexity for this simple language adaptation. Option D, few-shot, would also work but adds overhead. A simple output format constraint is more direct. Low GenAI 2.2.4 K3. Question 17. Learning Objective GenAI 2.2.3. Difficulty level K3. A test engineer has several existing test cases with defined inputs and expected results for an order processing system. They want to use an LLM to generate additional test cases that follow the same transformation rules and patterns. Which prompting technique is most appropriate? Your options are A. Few-shot prompting, by providing the existing test cases as examples to illustrate the pattern the LLM should follow. B. Prompt chaining, by breaking the test case generation into multiple sequential prompting steps. C. Meta-prompting, by asking the LLM to first critique and improve the prompt before generating test cases. D. Zero-shot prompting, by providing only a general description of the order processing requirements without examples. Take a moment. What is your answer? The correct answer is option A. Few-shot prompting, by providing the existing test cases as examples to illustrate the pattern the LLM should follow. Explanation. Few-shot prompting is ideal here because the existing test cases serve as concrete examples demonstrating the transformation rules to the LLM. By showing how inputs map to expected results, the LLM can replicate the pattern for new test cases. Prompt chaining would unnecessarily complicate this straightforward task. Meta-prompting is less direct. Zero-shot prompting would not leverage the valuable existing examples. Low GenAI 2.2.5 K3. Question 18. Learning Objective GenAI 2.2.4. Difficulty level K3. A test team needs to analyze the impact of a recent code refactoring on their regression test suite. The task involves 1. Identifying all test cases related to the refactored modules, 2. Determining which are likely to break, and 3. Recommending which to prioritize for re-execution. Which technique is most appropriate? Your options are A. Few-shot prompting, provide examples of previous impact analysis to guide the LLM. B. Prompt chaining, decompose into sequential steps, identify affected tests, determine break risk, prioritize re-execution. C. Meta-prompting, ask the LLM to generate a prompt for regression impact analysis, then use it. D. Zero-shot prompting, provide the module change log, and ask the LLM to complete all 3 steps in one prompt. Take a moment. What is your answer? The correct answer is option B. Prompt chaining, decompose into sequential steps, identify affected tests, determine break risk, prioritize re-execution. Explanation. Prompt chaining is most appropriate for this multi-step task with sequential dependencies. Step 1 output, affected tests, feeds Step 2, break risk analysis, which feeds Step 3, prioritization recommendation. Each step can be reviewed before the next begins, reducing error propagation. Few-shot requires suitable past examples. Meta-prompting adds overhead. Zero-shot in one prompt risks quality loss on this complex task. Low GenAI 2.2.5 K3. Question 19. Learning Objective GenAI 2.3.2. Difficulty level K3. Which prompting technique is most suited when a tester wants to quickly generate test cases for a well-understood feature where no examples exist and the task is straightforward? Your options are A. Prompt chaining to ensure each step is independently validated before proceeding. B. Few-shot prompting to provide the LLM with examples to guide the output pattern. C. Meta-prompting to let the LLM design the optimal prompt for this standard task. D. Zero-shot prompting to generate test cases directly from a clear, well-structured instruction. Take a moment. What is your answer? The correct answer is option D, zero-shot prompting to generate test cases directly from a clear, well-structured instruction. Explanation. Zero-shot prompting, providing a clear, well-structured instruction without examples or intermediate steps, is appropriate for straightforward, well-understood tasks where examples aren't needed and the task can be completed in a single prompt. Prompt chaining adds unnecessary complexity. Few-shot requires examples that don't exist. Meta-prompting adds overhead for a simple task. Low GenAI 2.2.5 K3. Question 20. Learning Objective GenAI 2.3.2. Difficulty level K3. A test engineer is asked to choose between few-shot and meta-prompting for generating test cases for a new microservices API. The team has no existing test cases for this API, but the tester is unsure how to write an effective prompt for this domain. Which technique should they choose and why? Your options are A. Few-shot prompting, because the LLM can infer examples from its general training data even without team-specific ones. B. Meta-prompting, because the tester is unsure how to write an effective prompt and wants the LLM to design or suggest the optimal prompt structure first. C. Prompt chaining, because microservices APIs always require multi-step analysis before test case generation. D. Few-shot prompting, because meta-prompting only works when there are existing examples to provide. Take a moment. What is your answer? The correct answer is option B, meta-prompting, because the tester is unsure how to write an effective prompt and wants the LLM to design or suggest the optimal prompt structure first. Explanation. Meta-prompting is best suited when the tester is uncertain how to craft an effective prompt for a given domain. The LLM is asked to first generate an optimized prompt from a general objective description, then use it to produce the test cases. No examples are needed for meta-prompting, that is its advantage over few-shot. Prompt chaining is about sequential steps, not prompt design uncertainty. Low GenAI 2.2.5 K3. Question 21. Learning Objective GenAI 2.3.1. Difficulty level K2. A test engineer is evaluating the quality of LLM-generated API test scripts. Which combination of evaluation metrics best ensures comprehensive coverage and script reliability? Your options are A. Diversity, to measure comprehensive coverage of edge cases, and test execution success rate, to evaluate reliability of the generated scripts. B. Accuracy and time efficiency, to measure the correctness and speed of the test script generation process. C. Precision and contextual fit, to assess how well-generated scripts align with the specific API domain. D. Relevance and contextual fit, to evaluate whether the generated scripts align with the stated testing objectives. Take a moment. What is your answer? The correct answer is option A, diversity, to measure comprehensive coverage of edge cases, and test execution success rate to evaluate reliability of the generated scripts. Explanation. For API test scripts, diversity ensures comprehensive coverage of different scenarios, edge cases, and boundary conditions. Test execution success rate evaluates whether the generated scripts actually run and produce reliable results. Time efficiency alone doesn't validate coverage or reliability. Precision and contextual fit are valuable but don't directly address whether scripts run successfully. Low GenAI 2.3.1 K2. Question 22. Learning Objective GenAI 2.3.1. Difficulty level K3. A test team uses an LLM to generate test cases. After review, they notice that the generated test cases closely match the provided examples but do not address alternative scenarios or edge cases. Which evaluation metric most directly identifies this quality issue? Your options are A. Accuracy. The test cases contain factual errors about the system under test. B. Precision. The test cases are relevant, but the proportion of edge cases is too low. C. Diversity. The test cases lack variety and do not cover a sufficiently wide range of scenarios. D. Execution success rate. The test cases cannot be executed as generated. Take a moment. What is your answer? The correct answer is option C, diversity. The test cases lack variety and do not cover a sufficiently wide range of scenarios. Explanation. Diversity measures the variety of scenarios, scenarios types, and coverage breadth in the generated outputs. When test cases mirror only the provided examples without exploring alternative or edge cases, diversity is low. Accuracy relates to factual correctness. Precision relates to relevance versus irrelevance. Execution success rate relates to runnability. Low diversity is the precise metric identifying insufficient scenario coverage. Low GenAI 2.3.1 K2. Question 23. Learning Objective GenAI 2.3.1. Difficulty level K1. Which metric would a tester use to assess whether LLM-generated test cases are relevant to the specific system and testing objectives, and are not simply generic or off-topic outputs? Your options are A. Time efficiency, the speed at which the LLM generates the test cases. B. Execution success rate, whether the test cases can be run without modification. C. Relevance and contextual fit, whether the outputs align with the stated testing objectives and the specific system context. D. Accuracy, whether the expected results in the test cases are factually correct. Take a moment. What is your answer? The correct answer is option C, relevance and contextual fit, whether the outputs align with the stated testing objectives and the specific system context. Explanation. Relevance and contextual fit measures whether the LLM's outputs address the specific testing objectives and system context rather than being generic. A test case can be syntactically valid and even technically runnable, execution success rate, but still be irrelevant to the actual feature being tested. Contextual fit ensures the LLM's output is meaningfully aligned with the task. Low GenAI 2.3.1 K2. Question 24. Learning Objective GenAI 2.3.1. Difficulty Level K1. What does the execution success rate metric measure when evaluating LLM-generated test artifacts? Your options are A. The percentage of generated test cases that are approved by the test analyst after manual review. B. The percentage of generated test scripts or test cases that can be executed without errors or modifications. C. The speed at which the LLM generates test scripts compared to manual authoring. D. The percentage of defects found by LLM-generated tests compared to all defects in the system. Take a moment. What is your answer? The correct answer is option B. The percentage of generated test scripts or test cases that can be executed without errors or modifications. Explanation. Execution success rate measures the proportion of LLM-generated test scripts or test cases that can be run successfully without requiring manual correction. A high execution success rate indicates that the generated artifacts are syntactically and structurally sound. This is distinct from approval rate, human review, generation speed, time efficiency, or defect detection rate, effectiveness. Low GenAI 2.3.1 K2. Question 25. Learning Objective GenAI 2.3.1. Difficulty Level K3. An LLM is consistently generating test cases with incorrect expected results that contradict the system requirements. Which approach most effectively diagnoses the root cause of this problem? Your options are A. Output analysis, by systematically examining and classifying the incorrect expected results to understand how the prompt misled the LLM. B. A/B testing of prompts, by creating two-prompt variations and comparing which produces more accurate expected results. C. Adjusting the length and specificity of the prompt to provide either more or less contextual information. D. Gathering structured feedback from testers about the usefulness and clarity of the generated test cases. Take a moment. What is your answer? The correct answer is option A. Output analysis, by systematically examining and classifying the incorrect expected results to understand how the prompt misled the LLM. Explanation. Output analysis directly examines LLM outputs for inaccuracies. By classifying the wrong expected results that contradict requirements, it reveals precisely why and how the prompt misled the LLM, providing concrete insights for targeted prompt refinement. A/B testing is better for comparing prompt versions than diagnosing root cause. Adjusting length specificity may help but doesn't identify the specific cause. Tester feedback addresses usefulness, not why expected results are wrong. Low GenAI 2.3.2 K2. Question 26. Learning Objective GenAI 2.3.2. Difficulty Level K3. A tester is refining a prompt used to generate test conditions. They create two versions of the prompt with minor wording differences and compare which produces higher quality test conditions across multiple runs. Which technique is being used? Your options are A. Output analysis, the tester is examining the outputs to classify errors. B. A/B testing of prompts, two prompt variants are compared to identify which performs better. C. Few-shot prompting, two example prompts are provided to guide the LLM. D. Meta-prompting, the LLM is being asked to generate two alternative prompts. Take a moment. What is your answer? The correct answer is option B. A/B testing of prompts to prompt variants are compared to identify which performs better. Explanation. A/B testing of prompts involves creating two or more prompt variants and systematically comparing their outputs to determine which produces better results. This is a key technique for prompt refinement described in the CT-GenAI syllabus. Output analysis examines a single prompt's output. Few-shot involves examples. Meta-prompting uses the LLM to generate prompts. Low GenAI 2.3.2 K2. Question 27. Learning Objective GenAI 2.3.2. Difficulty level K2. Which of the following represents an iterative prompt refinement workflow for improving LLM-generated Gherkin test cases? Your options are A. Submit prompt, accept all outputs without review, archive them in the test management system. B. Submit prompt, review output, identify specific weaknesses, modify prompt to address them, resubmit, repeat until quality is satisfactory. C. Submit prompt, ask a different LLM provider to validate the outputs, accept if both LLMs agree. D. Submit prompt, if outputs are poor, delete them and start again with a completely new prompt from scratch. Take a moment. What is your answer? The correct answer is option B. Submit prompt, review output, identify specific weaknesses, modify prompt to address them, resubmit, repeat until quality is satisfactory. Explanation. Iterative prompt refinement follows a structured improvement cycle. Submit, review output, identify specific weaknesses, example, missing constraints, wrong format, modify the prompt to address those weaknesses, resubmit, repeat until quality meets requirements. This is the systematic approach to prompt refinement described in the CT-GenAI syllabus. Accepting without review, external validation, or complete rewrites are not systematic refinement approaches. Low GenAI 2.3.2 K2. Question 28. Learning Objective GenAI 2.3.2. Difficulty level K3. A tester notices that an LLM consistently generates test cases without boundary value analysis scenarios. Which prompt modification best addresses this gap through iterative refinement? Your options are A. Switch from few-shot to prompt chaining to add a boundary value generation step. B. Add an explicit instruction. For each input field, generate test cases that specifically target boundary values, including minimum, maximum, just below minimum, and just above maximum values. C. Increase the temperature parameter to generate more diverse outputs that will naturally include boundary values. D. Provide the LLM with examples of test cases that happen to include boundary values and hope it infers the pattern. Take a moment. What is your answer? The correct answer is option B. Add an explicit instruction. For each input field, generate test cases that specifically target boundary values, including minimum, maximum, just below minimum, and just above maximum values. Explanation. The most direct iterative refinement fix for missing boundary value analysis scenarios is to add an explicit instruction specifying that boundary values must be covered. This directly closes the identified gap. Switching technique A adds complexity. Increasing temperature C affects randomness but doesn't guarantee boundary value coverage. Hoping the LLM infers the pattern from examples D is less reliable than an explicit instruction. Low GenAI 2.3.2 K2. Question 29. Learning Objective GenAI 2.3.1. Difficulty level K2. Which statement about the accuracy metric for evaluating LLM-generated test artifacts is correct? Your options are A. Accuracy measures the percentage of test cases that are relevant to the system under test. B. Accuracy measures the correctness of the generated outputs, whether they are factually correct and free from errors relative to the requirements. C. Accuracy measures the speed at which the LLM generates test cases compared to a human tester. D. Accuracy measures the diversity of test cases in terms of scenario types and input variations covered. Take a moment. What is your answer? The correct answer is option B. Accuracy measures the correctness of the generated outputs, whether they are factually correct and free from errors relative to the requirements. Explanation. Accuracy measures the factual correctness of LLM-generated outputs, whether expected results are correct, whether test conditions match requirements, and whether there are no logical errors. Relevance to the system is measured by relevance and contextual fit. Speed is measured by time efficiency. Scenario variety is measured by diversity. Low GenAI 2.3.1 K2. Question 30. Learning Objective GenAI 2.3.2. Difficulty level K3. A tester uses prompt chaining for test analysis. Step 1 generates test conditions. Step 2 prioritize them. Step 3 generates Gherkin scenarios. After completing all three steps, the tester discovers the final Gherkin scenarios are poorly structured. At which step should the tester intervene to fix this most effectively? Your options are A. Only at step 3. Add an explicit Gherkin format specification to the test scenario generation prompt. B. At step 1 only, improve the test conditions so they are more detailed and structured. C. At step 2, change how test conditions are prioritized to influence the Gherkin output at step 3. D. Restart from scratch without prompt chaining and use a single comprehensive prompt instead. Take a moment. What is your answer? The correct answer is option A. Only at step 3, add an explicit Gherkin format specification to the test scenario generation prompt. Explanation. Since the Gherkin structure is the issue, not the test conditions or prioritization, the problem lies in step 3's prompt. It lacks an output format specification for Gherkin syntax. The most targeted fix is to add a clear Gherkin format constraint output format to the step 3 prompt. Modifying step 1 or 2 wouldn't address a formatting issue in step 3. Abandoning prompt chaining is unnecessary for this specific formatting problem. Low GenAI 2.2.5 K3. That's all 30 questions for Chapter 2B, Applying GenAI to Testing and Evaluation. Well done for completing this chapter. If this helped, please like the video and subscribe to AmitAutomates for the next chapter in the series. The full CT-GenAI playlist covers all 5 chapters across 6 videos. Good luck with your ISTQB exam.